Hi, I'm Paul Battaglia, and this is section 9.5. I'm joined by Gabe and Brittany, and what we'd like to do is kind of walk you through this section because we are introducing a new system to students. They're used to seeing only the Cartesian plane at this point, but now we're introducing the polar coordinate system. So I like to try and motivate it just slightly by bringing in a Ferris wheel, and I think this actually gives students a very good visual of how the polar coordinate system works. And this Ferris wheel in particular is great because you can actually see the rings here. And then I like to talk to my students about the actual coordinates that we're going to be plotting. So I'll tell them, okay, we do have some differences. For instance, in a rectangular system, we had the origin, and now we have this point we call a pole. And so I'll say, that we can use the polar coordinate system to actually talk about the location of these points as we go around this Ferris wheel. And we can do that by the radius or the directed distance from the pole out and the angle at which the car sits from the pole itself. So I may go through just a couple examples and say, for instance, if we take a look at this car over here, if we count the rings, 1, 2, 3, 4, that the first coordinate of this point would be 4, and that the angle at which it lies is just simply 0 degrees. And we go around and we may say, okay, well, if you look up here, this is an easy one, also 4 units out, 90 degrees. And so the coordinates of this car would be 490 or 4 pi over 2. And as we continue to go around, I'll just ask them to kind of shout out different coordinates. And what this does right away is tell me if they at least get the concept, Yeah. So I guess where do we go from here, right? Brittany, it would be nice if we could just give everybody a Ferris wheel and they could just do that, right, at their desk. So how do you go about it with students?
So what I have them do is plot numerous points on the polar coordinate system.
Right.
And what I want them to see is that there are multiple ways to write out the same point.
Okay, oh, perfect. I think you may actually, if you're looking to see if we can get accuracy here, online software and even there's a lot of resources online where you can actually print out this kind of paper, polar coordinate system paper, so you don't have to just kind of keep drawing rings and things like that nature. But I guess the best part to go from there is now students can plot all these points. They've seen multiple representations. Gabe, where do I want to go from here?
Sure. So students have already seen this rectangular coordinate system,
right.
And now we just introduced them to this polar coordinate system. Well, really we're plotting points,
right.
And there has to be some way to go from one system to the other,
right.
And vice versa.
Right.
So really what I like to have students do is think about, well, what happens if we place the pole at the pole in our polar coordinate system
right.
at the origin
Correct.
on our rectangular coordinate system, and have the polar axis coincide with the positive x-axis.
Right. Okay.
So now we can start having a conversation about, well, what do we know from trigonometry that
right.
might help us represent a point in the rectangular coordinate system
right.
to some distance and an angle in this polar coordinate system. And as we have this conversation, students might start to realize, well, maybe there's some formulas here that I can use to convert from polar to rectangular,
right,
from rectangular
right.
to polar.
And I think that the idea of building on that prior knowledge is just always so important. I think being able to tie that in for students is really helpful. I hope these tips have been helpful for you and you find much success in section 9.5.